All right. Hi, guys. So today we will be working through section 372 in our textbook, which is going to kick off our last big section for this unit. So we'll talk about what that looks like in a sec. Remember that your homework for today was to complete the Solving Systems Alex assignment as we reviewed solving linear systems of equations by substitution and elimination method yesterday. Um, so for today, we are going to solve systems using algebra where it's a quadratic function and a linear function. We'll continue to do that tomorrow. Then we'll finish that lesson up on Monday, might even leak a little bit into Tuesday, might even just use Tuesday to just kind of review everything that we've done this week with me being out. Um, we are going to review next week on the 26th and 27th, Wednesday and Thursday, and then our unit test is next Friday. Okay, so that's where we're headed. If you guys want to get out your textbooks, we'll be in section 372 in there. One sec. So our target for today, we're going to find the solutions to a system consisting of a linear and quadratic equation using algebra. Okay. So we're looking at a linear and quadratic function together. So remember, the solution to a system would be the intersection points, the points in common between the two functions. So if we think about possibilities when we have a quadratic function and a line, okay, it's like if we drew an xy plane here, we have our parabola. We really have three possibilities. We could have a line that goes directly through the middle, where we have two intersection points or two solutions. We could have parabola. We could have a line that only intersects at a single point, meaning we only have one solution. And lastly, parabola, we could have a line that never intersects, meaning there's no solution. So we will see algebra problems where we see all three cases in there today. Okay, so remember, solution to a system of equations is the common intersection points between the two functions. So these are our cases. We could have two solutions, two ordered pairs, one solution, one ordered pair, or no solutions, no intersection points. Okay. We're going to use algebra. We're actually going to go back to what we did yesterday. Okay, we're going to use substitution method today again. Okay, it's just we're going to have a quadratic and linear function together. So let's see what we mean by that. So if we open up our textbook, I'm not sure if this page number is right. This is from an old document of mine, so you guys are going to have to double check. But we're looking for the warm up for section 372. Okay, and this is just review from yesterday, so we see a little bit of substitution method. So they give us a system here. It says a plane flies 900 miles in 3 hours with a tailwind. It takes the same plane 5 hours to fly 900 miles with a tailwind. So here's our system. Okay, I'm just going to rewrite it. It's kind of written with this odd multiplication on the right-hand side, which looks kind of weird. So I'm actually going to bring the numbers to the front just because that's how we typically see a number in front of a set of parentheses. So we have 900 equals 3 times r plus w, and 900 equals 5 times r minus w. Okay, so it says use substitution to solve the system of equations. Okay, kind of a messy problem here. So we are going to use substitution here. First thing we're going to do is we need to take one of the equations and solve for a variable. So why don't we just take this top equation, let's multiply this out. So we have 900 equals 3r plus 3w. For all these coefficients, so maybe let's just try to solve for r here. So if we subtract it over the 3w, then we'd have 3r equals 900 minus 3w. Divide everything by 3. So now we have r equals 300 minus w. Okay, so now we can substitute. So we're going to take this 300 minus w, and that's got to go in for r in this other equation. Okay, so let's write that down here. 900 equals 5 times, we're going to replace r with 300 minus w. So we have 900 equals 5 times 300 minus 2w. Can distribute. Let's see, 5 times 300, 1500 minus 10w. Subtract the 1500 over negative 600 equals negative 10w. Divide by negative 10. W equals 60. Coming back to earlier, then we can substitute in our value for w to see what we get for r. So r is going to equal 300 minus 60. R is 240. So those are our answers. We went back to what the question was asking. Expresses the distance of the plane where r is the speed, while in still air, and w is the speed of the wind. Okay, so w is speed of wind. So this is 60 miles per hour, right? It was measured in miles and hours. Yeah. And then 240 miles per hour. Okay. So that's a linear system of equations where we use substitution. That's all stuff we've done before. We did that yesterday. We didn't do it with word context problems, but we practiced those skills. Let's get into what's new. Okay, so if we go to example 1, it says solve the given system of equations algebraically. I'm going to use the same steps as what we did with a linear system, but now we have a quadratic function involved. So we have y equals x squared minus 11x plus 28, and y equals negative 3x plus 12. We did problems like this yesterday. We just didn't see an x squared term in there. Okay, so we can still substitute. So let's take negative 3x plus 12 and put that in for y in the other equation. So then we'd have negative 3x plus 12 equals x squared minus 11x plus 28. Notice what we have here. We have a quadratic equation with just x's. This is what we did all of the end of first semester and even earlier in this unit, right? We can solve this quadratic equation. So first thing we'd want to do to solve this quadratic equation is let's get it equal to 0. Add the 3x on both sides. So we'd have 12 equals x squared minus 8x plus 28. Subtract over the 12. So now we'd have, I'm going to write this on the left side because that's where you can usually see it written. X squared minus 8x plus 16 equals 0. And we have a quadratic equation equal to 0. So now if it does factor, let's try to factor it. Factor the left side to x. 16's in the back. Common factors 8 and 2, 4 and 4, 16 and 1. For making a minus 8x, we'd want a minus 4 and minus 4. So we have x minus 4 equals 0. X minus 4 equals 0. Same equation for both. Add over the 4, we get x equals 4. Not quite done. Okay, this is just the x coordinate of our intersection point. So notice, since we had the same answer here for our x's, there actually is only going to be a single x value, which is telling us in advance that we're only going to have one solution. There should only be one point of intersection between the parabola and line. So if we come back to the beginning, let's put in our x value of 4 into one of these original equations to find the y. I would suggest go to the linear equation, so it's a little bit simpler with the algebra. Because we know it's a shared point, we'll get the same answer regardless of whether we put it back into either of these equations. So we'd have y equals negative 3 times 4, and then it was plus 12. So that'd be negative 12 plus 12, so we get 0. So our solution would be 4, 0. That's our answer. Let's check our solution with a graph, and this is what we'll do a lot more on Monday. Honestly, I chose to go past this section because with graphing, there was a lot of problems I'd like to do on more of like a handout packet, and I just wanted to keep things simple and work out of our textbook or take notes when we could while I was gone. So we'll come back to solving by graphing, but we can create a graph of each of these functions and verify that that is our solution, 4, 0. I just made like a little table of values here of each of these. Okay, we could graph this with the slope and the y-intercept, but our scales are kind of not helping us here for graphing a y-intercept and using points here, but we can plot some of these points. So we have our line at 4, 0 is this point here. It says 5, negative 3. Okay, so it'd probably be like around here. We have 2, 6, somewhere up here. Okay, so here's our line. And then our quadratic parabola over here, we have our shared intersection point of 4, 0. It says 4.5, negative 1.25. If we look at this, we keep going. Looks like our vertex is at 5.5, negative 2.25. It's 5.5, negative 2.25, somewhere around here. We know we have symmetry where 7, 0 would be where our vertex is at. And we can just kind of draw in this sketch. We see that this would only have one common intersection point, okay, which is our solution. So that's one possible case. We could only have one intersection point. Let's do some other examples. So if we flip the page, example 2, we're still going to use algebra. Okay. So we can take, I made some notes off to the side, but this is more, I don't know. So before we begin, we could consider the type of each graph we'll make and how many possible intersection points there are. We know there's either 0, 1, or 2. We don't necessarily need to check them in the calculator at the beginning. We'll know that based on what our answer is when we substitute this in. Okay, we're going to take our x minus 1, let's put that in for y in the other equation. So instead of y, we'd say x minus 1 equals 2x squared plus 13x plus 15. Now we solve our equation. Let's first get it equal 0, minus x on both sides. So we'd have negative 1 equals 2x squared plus 12x plus 15. Add over the 1. 0 equals 2x squared plus 12x plus 16. Let's factor this. Okay, so we have a GCF of 2. We have x squared plus 6x plus 8. Factor the inside. X. 8, we'd have 8 and 1, 4 and 2. 4 and 2 would work to give us the plus 6x, plus 4 plus 2. Now we can solve. Okay, so we'd say x plus 4 equals 0, and x plus 2 equals 0. So we get x equals negative 4, x equals negative 2. Let's get the y's now. So we're now done. So let's come back. Or we could use either of these. We have the same thing, but let's use the linear one, y equals x minus 1. So we'd have 2 that we have to substitute in. So y equals negative 4 minus 1, and y equals negative 2 minus 1. So we get y equals equals negative 5. And y equals negative 3. Make sure you put them in the correct spot. So negative 4 and negative 5 is our first point, our first solution. Negative 4, negative 5. And then negative 2, negative 3. I put the graph here as a reference where we can confirm we have this line and this parabola as our original functions. Okay, and here's our two intersection points. Okay, negative 4, negative 5, and negative 2, negative 3. Okay. We can keep going. Let's try another one. If we look at example 3, let's substitute. So we'd have negative 3x minus 30 equals 7x squared minus 25x minus 12. Get this equation equal to 0. Negative 30 equals 7x squared minus 22x minus 12. Add the 30 over. 0 equals 7x squared minus 22x plus 18. So we should try to factor this if it does factor. And this would be where, as I kind of put as a note, oops, sorry about that. Sometimes it's helpful to look at what the graph would look like in advance to get an idea. Okay, it looks like we're going to have one solution here, hopefully, or maybe not. Okay, you'd have to really zoom in there. But let's try to factor it. Let's see if it factors. 7x. Well, the plus 18, we'd have 18 and 1, 9 and 2, 6 and 3. We know minus plus, we would need minus minus. We could start trying things. 18 and 1 would not work. 9 and 2, if we went 9 here, 2 there, not quite. 2 and 9, definitely not. And then 6 and 3, we put the 3 here, 6 there, nope. 6, 3, nope. Doesn't factor. It's okay. Why don't we solve this with the quadratic formula then? So we'd say x equals opposite of b, positive 22, plus or minus square root b squared, negative 22 squared, minus 4 times 7 times 18, all over 2 times 7. X equals 22 plus or minus. Sorry guys, I thought my calculator was open. Disappeared on me. Give me one sec. Sorry about that, guys. Someone closed out on me. Let's get back to here. Okay. So we have, okay, so inside our square root, we have 22 squared. I didn't put the negative because we know that's going to make it positive. Minus 4 times 7 times 18. Negative 20. Over 14. Well, if we were getting an exact answer here, we could simplify this. Okay, square root of negative 20, so it's probably good practice. So we'd have square root of 20 times square root of negative 1, which is our I. Square root of 5 times square root of 4. over 2. So we'd have x equals 22 plus or minus 2I root 5 over 14. Each of these have a GCF of 2 that we could get out of there. So we have 11 plus or minus I root 5 over 7. But what does this mean? Well, we're getting two imaginary solutions here. If we looked at our graph, remember I said like this original graph, can't really tell what's going on there. It looks like maybe one solution. There could even be two if we zoom in far enough. If we zoom in really close, they actually don't cross, which makes sense here why we got imaginary solutions for an intersection point. There's no solution here. Right? There's no real solution here. They never cross. There's no common intersection point. Okay? So that's what we're doing today. We're using substitution with a line and a quadratic function in order to solve for the intersection points, or in this case, there was no solution, right? They never intersected. Okay, so let's get some practice with this. It's through some together. If you guys want to pause this and try working on these two, and then I'll show the answers in a sec so you get some quick feedback. Okay, here's what we should have got for these two. Okay, you want to check over your work, you want to pause it, look through it, just so you guys get some quick feedback for yourself. And then another one, another pair. Okay, if you want to work on these two, then you can pause, work through these, get some feedback and look at how you did. These should be the solutions here. So notice this one came out to an imaginary solution, so we had no real solutions, no intersection point. Okay. Homework, I'm just posting this as a PDF because these are easy to just copy down. There's no point in me trying to arrange for copies to be made at school of this. So you guys can just as easily write these down on notebook paper. So I'm assigning this worksheet. I have the PDF on Classroom linked where there's 8 problems for you guys to do. Okay, so that'll be our homework for tonight. And that'll be what I'm checking in when I come back to class. Okay. As always, if you guys have questions on this, feel free to reach out. And I hope you guys have a good rest of your day. And I hope to see you all very soon.